Hello, hello. Am I audible to all of you?
You're audible.
Yeah, yeah. Okay. So I think we can start now. We can't wait for others to come for the lecture now. Okay. There are something 9 participants are there, including me. Okay. So we'll start with the today's
Eight, I
lecture.
think eight, because that moderator will be also included in that Indian Plastic
Yeah, yeah,
Institute.
yeah. Yeah,
Yeah,
maybe seven are there, and I
seven,
think one is double. Okay. Only six of you are there.
six. Yeah,
Okay.
yeah.
So are they means are other are joining or
I don't think other will join because already 10 minutes. If
okay.
anyone is
So
supposed to
can we
join,
start now?
yeah, we can start.
Yes, sir.
Okay. Okay, okay. So till tomorrow, I think you have studied many of the plastic materials, correct? You have already started with the started learning the plastic materials part, correct? I think 5 to 6 class of plastic materials you have already studied in recent 5 lectures, correct? Which are which were been taken by I think Namita ma'am. Okay, what all plastic materials you have studied? Hello. Can you just brief
Like
what?
uh,
Yeah.
like nylon, polycarbonate, and
Yes.
all.
Okay. Nylon, polycarbonate. Then
ABS,
I think which one?
ABS.
ABS. Okay. And then I think polyolefins means something polyethylene,
Yeah,
polypropylene.
First we started with polyolefins only.
Okay. Polyolefins only. Then I think polystyrenes will be there. Correct.
Polystyrene, ABS, all this.
Yeah. Okay, so continuing to that thing, we will again like some of the plastic materials are remaining to study. Okay, in which polyester, polyphenolics, polyamino, and polyfluorines. Okay, many are there. Out of which we will start with polyester today. Okay, so all of you heard about the polyesters.
Yeah,
Okay, so can you tell me one of the example or any one of the example of polyester that you know about?
that that fabric we are using
Yeah,
polyester fabric.
fabrics or yeah, correct. Polyester fabrics we are using that are made of nothing but like polyester only, which is a kind of plastic material again.
And
Okay,
polyepoxy is also different thing, or polyester only?
poly
Epoxy resin.
epoxy is totally different thing.
Okay, okay, then it's
Okay,
different.
epoxy is totally different thing.
It
Okay,
will come under which category?
yeah,
Polyepoxy?
it is come under only epoxy section.
Okay, okay, okay.
Okay, epoxy is a separate class of material.
Okay, got it.
Okay. Yeah. So again, which all materials except like now we are having clothing or we can say to fabrics or polyester fabric. Any other example in daily life can you tell or means any of the example have you seen of polyesters? Here on screen, I have given some of the examples of polyesters.
Oh,
Okay.
sorry, I forget. So basically, I got it now. I recall that PET bottle, right?
Yeah, yeah, yeah. Correct. One of the
Then
example I have already shown you
the
on the
same thing
screen.
we are using in that automotive. This I can say,
Yes.
and roof liner, all this layer of.
Yeah, but automotive roof are mainly prepared by other kind of polymeric material that we will see again in some of
That's
the
what it's a kind of a layer of PET also, because I observed many PET layer also we are using for insulation,
yeah,
car
for
also.
insulation maybe there.
It's a part of PET
But
only.
for now we are having some of the examples of polyesters are nothing but here PET bottles or we can say to it polyethylene terephthalate bottles. PET is nothing but a full form of PET is polyethylene terephthalate. Okay. Generally, all of you know the polymer by name of PET itself, correct? How
Correct.
many of you know the full form of it? Like I have told you just now.
Uh,
Before you have known it, or
Knowing we know that.
okay, okay, okay. So it is nothing but a polyethylene terephthalate. It is nothing but a class of polyesters again, correct? So again, if you see some fabrics,
But
as you
polyethylene, it's a ethylene group, or
no, 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 no. Ethylene is totally different, which comes under your polyolefins only.
okay, okay, it's a
Okay,
different. Okay,
this ester or polyester is totally different. Means polyester family means we can say like you have already studied the olefin family of polymers. In olefin, which all polymers comes under that family, that is polyethylene, polypropylene, polystyrene. What all are there? I have already told that polyethylene, polypropylene, polyester. Then you can say PVA, we can call it as a polyvinyl alcohol, correct? So all of these comes under your polyethylene family, correct? So again, if you see polyester, polyester is nothing but not a only one polymer. It is also having a many of the plastic materials comes under polyester family. Okay, so that one by one we will see. But for now, what all kind of applications are there? Just to understand the things, that is nothing but the fabrics, as you mentioned just now, that polyester fabrics are there, correct? Then PET bottle is none of the like one of the major example which you seen in your daily life, correct? PET bottles. Okay, so for your understanding now, before starting the polyester part, we will go through like only for 5 to 10 minutes for the basic of your polymerics, just to remind you all of the things which comes under your basic polymer, correct? Which I think Jyoti sir and I have taught you before, like polymer and polymerization chemistry and that all, correct? So we'll just revise in 5 to 10 minutes. Will it be okay for you?
Yeah.
Yeah. So what is polymer first of all? So all of you know that polymer is nothing but a giant molecule, or we can say macromolecule, which form using many repeating units, which we call it as a monomers. Correct? Okay. And the reaction by which polymer is formed, it is we call it as a polymerization. Correct? This is clear to all of you.
Yeah.
Yeah. Then there are two types of polymerization. One is addition polymerization and one is condensation polymerization. I only taught you before, I think, before that Navratri and all. In that lectures, the same slide was there, correct? Okay,
Right. Right.
the same slide was there for explanation of addition polymerization and condensation polymerization. What you learn in addition polymerization? Hello?
In addition, polymerization, it's there's a no reduction or
No byproduct is
it's
there.
combining only.
Yeah, it is
But
only
in
the addition
condensation,
of your next molecule to it, correct?
but in
Your
condensation, some part is removing like some
Yeah, in
droplet of.
condensation polymerization, some part is removed in form of water or any other moiety, which is nothing but a byproduct of your reaction, correct?
Correct.
Okay, this is nothing but the basic difference of the basic difference between your addition and condensation polymerization. Okay, addition polymer is generally happened with your vinylic, or you can say as you have studied the polyvinyl, correct? Which kind of polymers you have studied? Polyethylene and polyethylene, polypropylene, polystyrene, correct? Which is nothing but the addition of your next monomer to your chain. Here you can observe addition of your monomers continuously. Okay, that is nothing but your addition polymerization. In condensation polymerization, what happen? By adding or we can add from both the ends, correct? See, if here you can observe that to the monomer from both the ends, you can add the monomers, correct? And one of the raw material, one of the byproduct will get separated. Have you observed that here? Hello.
Yes.
Yeah.
Um,
So in condensation polymerization, byproduct will be there. Okay. So these are the some basic differences between your addition polymerization and condensation polymerization. Now, out of this, by which method we are polymerizing polyester, that we will see. Correct? Because I think in previous 5 lectures, you have already studied that each of the polymers are synthesized using which technique. Have you studied that? Hello.
Yes, sir.
Yeah.
Yes, sir.
So
Yes, sir.
the we'll start with like
Sir, one doubt.
yes,
Hello.
yes, yes.
This polymerization and synthesize. The word polymerization and word synthesize. Is there any difference between these two?
No, actually, if you are going to means if you are going to prepare some material out of two raw materials, correct? Suppose if you are having some acid and some base, if you are mixing it and you are preparing salt out of it, correct? So it is nothing but the some kind of chemical synthesis you are doing it, correct? Here, what thing is there? We are adding monomers to synthesize the polymers, correct?
Okay.
That
Okay.
is nothing but the synthesis of something or preparation of something. You can call it as, correct?
Okay.
Polymerization is nothing but a synthesis one. There is no difference between that. Okay. One
Okay.
of the method to form or the formation of polymer, we can call it as a polymerization. The reaction we can call it as a polymerization, which is nothing but the synthesis of. Okay.
Okay. Okay, sir.
Uh, now we will start with like synthesis of polyester. Correct. Can you able to see the title because one of the ribbon came under the screen. That's why. Are you able to see? Yes.
You can see introduction only.
Okay. Introduction. Correct.
Correct.
I think one ribbon is there. Okay. So introduction to the polyester. So polyester, the word itself suggestive. Poly means many. Again, as you are knowing that polymer. Polymers means many units. Correct. So here also polyester. Correct. Polyester is out of if you separate the word, how you will separate it? Poly and ester. Correct. Okay. So poly is nothing but the many units, and ester means what exactly we can consider ester is. I think on very first lecture, that same lecture that I was repeating that slide before, that addition polymerization and condensation polymerization. In that lecture, I have mentioned that functional groups and linkages. Do you remember that? I have mentioned one word, linkage. Do you remember that thing? Hello?
Maybe you can repeat maybe.
Yeah. Okay. We will repeat that thing. In many of the polymers or in many of the chemistry molecules, there are some linkages and functional groups. Okay. So I have already explained you that thing, but here we will consider like if you see these reaction structures. Okay. The here I have mentioned nothing but like a dicarboxylic acid. Have you seen this? Dicarboxylic acid here. Can you able to see this cursor, red
Yeah,
color?
right.
Okay.
Yeah.
So this is nothing but the dicarboxylic acid. Dicarboxylic means di means two, carboxylic means this functionality, COOH, correct? This is nothing but your carboxylic group or carboxylic functional group, we can call it as. Okay.
Sir, one request. Can we get that handy notes of this structure? Because
We
like that.
can't provide the handy notes, but I can share this PPT immediately after the lecture. Will it be okay for you?
Yeah, PPT will be future, that is good, but
Yeah.
that any handy note, because
Handy
earlier
notes are
also
not there,
earlier I think
but
also that Kalanidhi requested that if you can get any handy notes, handy
because
formula, all
see,
this kind of.
all of the formulas or all of the structures are already been there in the PPTs, correct?
Yeah,
We already are we explaining the things from it only. But if you want something more, you can search it on, or you can search it on like you can see online things or net. You will get it, but we are not having handy notes with us. We are
okay,
having PPTs that we can share you. Okay, I have collected all of the recent PPTs from my colleagues. Okay.
great.
Yesterday only I have got all of the PPTs. Okay. That PPTs I will share immediately after the lecture. Okay. By
Okay,
tomorrow, I think you will get the PPTs by your coordinator. Okay.
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 So there
So
here dicarboxylic acid is this COH only.
yeah, COH is nothing but the acid group, or you can say carboxylic acid functionality. Correct?
Okay,
COOH. Correct? Here, two number of COH are there. That's why it is nothing but a dicarboxylic
got
acid.
it, got it.
Correct? And if you see the second molecule here, which is nothing but the hydroxyl functionality, OH. OH means nothing but the hydroxyl group. Okay? And there are two OH functionalities are there. That's why it is nothing but the diol. Okay?
Okay.
So polyester, or we can say ester. Ester is nothing but we can call it as a linkage or the product by reacting this acid with this alcohol, or we can call it as a hydroxyl. Okay.
Okay.
Acid with alcohol will give you this ester linkage. Have you observed this green highlighted part?
Yeah, yeah.
Okay.
CO double
Yeah,
bond single bond.
this
Okay.
green highlighted part is nothing but the ester linkage.
This is a structure. Chemical
Yeah, this is nothing but the ester structure. Polymer is what? Polymer is nothing but a chain structure, or you can say chain molecule, which is formed using addition of or whatever the addition of monomers to or repeating unit. Correct? It is nothing but a long chain. Correct? Polymer is nothing but a formation of long chain. Is this clear to all of you?
Yes,
Hello?
sir.
Yeah.
Yes, sir.
So here you can observe long chain is there, but we have showed this bracket and n. N is nothing but a number of means whatever the number. If n is like 10, then this whatever the unit is repeating in a 10 times. Correct? So we'll come back to ester. This is whatever the green highlighted part is nothing but your ester group. Okay? Have you observed this? Okay. So this is nothing but your ester group, which is formed by reacting this carboxylic acid with this hydroxyl group.
Uh,
Correct?
One doubt, actually, how during this reaction, at least one polymer, one monomer molecule, if you want to see how much time it takes to prepare this
Time to prepare the polymer you are asking.
polymer as a molecule, a visible content, if you want to transfer it.
Okay. See, again, if you are synthesizing this polyester, or here as we have taken the example of polyester, it depends on your monomer concentration or your molecular weight, which we are forming. Okay. If you are forming low molecular weight compound or low molecular weight polymer, then it will take less time. Or if you are adding monomers to it again and again, so high molecular weight polymer will get formed, correct? So it will take some more time. Okay. Depending on your reaction conditions and all, your time will get vary accordingly. Okay.
Is it in hours, seconds, minutes?
It's hours.
Okay.
Hours.
In a hour,
Because polymer is a giant structure, correct? To form a giant structure, it will take some more time, correct?
okay. So it needs hours together to
Yeah,
create
it needs hours.
polymerization for polymer.
Yes, correct.
But once it has started to do that, well, after that, whether it will be continuous or again
It is a continuous process.
continue.
Continuous means it is not like you are removing product time wisely. The
Uh-huh.
reaction is continue in a vessel.
Okay,
It is batch process only.
okay. So
Okay.
it will be like what we do atta like that only. For dosa atta, it's a batch production. We have to create and keep it
Yes,
separate.
yes,
Will form. It's
yes.
like that only.
Okay.
Okay, then in a industry there will be multiple reactors where the same thing will be.
Yes, if you see in the polymer industries, many kind of reactors are they using, correct? In that also they have some like suppose some of the reaction will take 6 hours, then they just charge the things and or whatever the charging process is there, stepwise or continuous in that way. After 6 hours, your polymer will get formed. I'm just taking the examples of 6 hours. Don't consider it for all of the polymers. Okay.
Okay, but normally in a power press or something we call it 250 ton or 50 ton and all. So what
Yeah,
will
yeah. It
this?
is again dependent on your batch size and the reaction conditions.
Uh, is there any
Okay.
specification or something for the reactors like 250 ton, 100 ton like that? Anything like that?
Yeah, dependent on it is obviously it is dependent on the capacity of whatever the plant or whatever the requirement in that way. It starts from 8 kg, 50 kg, 100 kg, 1 ton or 100 tons in that way. Whatever the requirement in that way, it will vary.
Okay, sir. Okay.
Okay. Yeah. So here this is nothing but your ester linkage. Okay. whatever the polyester or esterification, the reaction we called it as a esterification because out of your acid and alcohol, you are getting ester, correct? So while forming the ester, as it is a condensation polymerization, I am again telling this is nothing but the type of condensation polymerization. So one of the byproduct will get released. So which byproduct will get released is nothing but the H2O. If you see the functional groups here, this is nothing but the COOH and this is OH, correct? And what linkage here forming? COO, correct? Hello? Yeah, COO, that is ester linkage is forming. So remaining part like H from this, or you can say H from this and OH from this will get combined and your water molecule will get released. Have you understand this? Or you can see visualized, I have mentioned here. See, two molecules, one is like acid molecule, correct? Which is having two acid functionalities at the end. Have you observed this visualization?
Yes,
Can
sir.
you have, okay. One, see, ethylene glycol, okay, which is having two hydroxyl molecules, and this is nothing but the two acid molecules. And if you see, it is combining to form your ester linkage and releasing water molecule. Correct? This polymer is known as a polyester, or you can say, as in this, I have mentioned names of monomer, that is terephthalic acid, okay, terephthalic acid and ethylene glycol. Okay, in next slides that structures are being mentioned over there. Okay, we will see in next slide that. But have you understand how that molecule, two monomers will get attached and form ester and release the water molecule? Correct? Have you
Yes.
understand this part?
Yeah, understood.
Okay, this PPT will I will share with you. Okay, you will understand by structure that is. Okay, so we'll see how or the basic of ester or esterification. So esterification is the reaction between acid and alcohol, as I already mentioned. It will form ester linkage and liberate or byproduct is your water. Okay, the formation of polyester is an example of condensation polymerization. Correct. Polyester is a chain molecule formed by many basic ester molecules through condensation reaction. Basic means nothing but your diol again. Whatever the polymer chain will form, it is nothing but a chain in the form of chain, long chain. You can consider it as a okay. At each ester link formation, a water molecule is given off. See here you can see after each ester formation, one water molecule will given off. Have you observed that? Hello, hello. See here after formation of each ester linkage, one water molecule will get off. Correct? Hello.
Sir, yes,
Yes,
sir.
yes, sir.
Okay, okay. So monomers that form polyester have minimum two functional group requirement. Means whatever monomers you are using for polymerization, it should have two functional groups at the end. Correct? Here, if you observe dicarboxylic acid, there are two functional groups, that is two acid groups. And if you observe this diol, there are also two functional groups are present over there. Correct? So we will see examples of polyester now. All of you understand what is polyester now here? Then we will move to the examples.
Sir, the above sketch it calls dicarboxylic acid and adiol. Below,
Diol.
you are telling about ethylene glycol and terephthalic acid. So both will form only ester. Huh?
See, this is nothing but the general representation of dicarboxylic acid. Okay, whatever the blue color block is there is nothing but again something molecular structure will be there. Okay, this is general representation. Like what is the requirement of forming polyester? The requirement is this. Whatever the inside is there, that structure is different again. But in every polyester formation molecules or monomers, you will observe these functionalities. Okay.
You mean to say ethylene glycol is a
Okay,
dicarbon?
if you consider ethylene glycol, correct? Ethylene glycol is nothing but a diol. Okay,
Ethylene
ethylene,
glycol is diol.
yeah, yeah, it is nothing but a diol. It is having two hydroxyl functionalities at the end, and as its name suggests, ethylene, correct? So ethylene means CH2CH2. That red block consists of two CH2 over there. Okay, that we will see in next slide. Next slide, I have mentioned that. Here, only the thing what I have asked is, have you understand the ester formation part or polyester formation part by this visualization?
Yeah, yes.
Okay, so can we go forward?
Yeah, yes.
Yeah. So before that, this is nothing but a history of polyester formation, when it will get invented or when that polyester get invented. This is nothing but a history. Polyester has been founded by DuPont. Okay. So we'll come back to the example, which is nothing but a polyethylene terephthalate. Okay. This is nothing but the commonly used polyester in plastic industries, which we commonly called as a PET. Correct? Polyethylene terephthalate is nothing but the PET, which is kind of saturated polyester resin or saturated polyester plastic or polymer, you can say. So generally, polyesters having two categories. One is saturated polyesters and second is unsaturated polyesters. Okay. So out of which we will see first of all saturated polyester resins. So what is the difference between saturated and unsaturated polyester resins? Okay. So we can, I will explain you like, what do you mean by saturated? Any one of you knowing the thing?
It is stable.
We can say it is a stable. Yes. Then,
After that, there will not be any further reaction.
okay. Then,
Unsaturated, it may get react to any external this thing.
okay. So here in this case, saturated means, as he said, it is having a stable structure. Okay. But in case of saturated and unsaturated polyesters, okay, we will see here like in which structure saturation means, or unsaturated, we will take first unsaturation. Unsaturation means presence of double or triple bond linkage or double or triple bond molecule in your structure. I am not saying that these double bonds which are present in your ring. Okay. I am saying that CH2 double bond linkages, which I think you observed in uh, polyethylene, means ethylene molecule. All of you know the ethylene,
Yeah, yes, sir. You told.
correct? CH2 double bond CH2. Okay. We called it as a unsaturated structure. Okay.
Okay.
And against,
Unsaturated structure
because presence
the
of your
outer
pi
valence
bond over here, that
electrons
pi
are
bond
not,
will further react it to form your polymerization, correct?
or you're telling in terms of bond, or
Yeah,
maybe
in terms of bond, I am telling here.
or
Okay,
maybe
because
you,
that is the
if I
easy
talk
way
in
to
terms of
understand.
atom, there are outer electrons are freed to make a bond like
Yeah,
that.
yeah. Pi bond, which is nothing but some, you can say, uh, hello.
Yeah.
Yeah. Okay. So ethylene, if you consider the ethylene molecule, it is nothing but the unsaturation structure or unsaturated structure. And again, if you consider CH3 single bond CH3 structure, normal, in which only, or if you see here, ethylene group I have mentioned here. Do you observe this ethylene group? Hello. Can you able to see these?
Yes, too.
Correct.
Yes,
Yes.
sir.
Here only one covalent bond, or you can say only single bond is present. Okay, no unsaturation is there. That's why it is, we can call it as a saturated structure. Correct.
Yes, sir.
So the difference is clear in between saturated and unsaturated structures. So there are two types of polyesters. One is saturated polyester and second is unsaturated polyester. So in first class, we will see saturated polyester resins or saturated polyester polymers. Correct. So very first example in saturated polyester is nothing but your polyethylene terephthalate, or we generally called it as a PET as a short form. Correct? So how your polyethylene terephthalate or PET will form? Which monomers are there to form PET? Okay, that is the next question to all of you. Correct? So if you see the structures over here, have you seen these two structures where I have moved my pointer, red color pointer?
Yes,
Have
functional group is separate and this is also there. CH,
okay. Here are two structures I have presented here. One is like this ring and attached with two acid functionalities. These are not this is nothing but your carboxylic acid. Okay, there are two carboxylic acids in one structure, and if you observe second structure, here are two hydroxyl functionalities are there. Correct?
okay.
How that carboxylic acid means? Didn't get your point. Sorry, please.
Yeah. Correct. So if you see very first slide over here, correct? The basic requirement of monomers to form polyester. Correct? If you see here, we are having dicarboxylic acid. Correct?
Okay.
Yeah. Dicarboxylic. Carboxylic means COOH. This functional group is nothing but your carboxylic acid functional group.
Okay.
Okay. As per the requirement, if you see the very first monomer over here, which contains your carboxylic acid
Okay,
functional
got
group.
it. COOH, right,
Correct?
right.
COOH at both sides, or you can say both ends. Correct? Means
And
two functional groups are there.
that is a COOH. And what is that in between that hexagon shape?
Yeah, this is nothing but you can consider benzene ring here. Okay.
Okay.
This is the structure of your terephthalic acid.
Okay.
Okay. Terephthalic acid is nothing but a chain and attached with these two acid functional groups. Okay. Now here first requirement is completed.
But second one, bottom, it is HO and O. Is whether it is CH or HO?
This one, no?
Not left side, left side. After the oxygen, after the benzene below, there is
This
HO.
is COH again.
It's CO,
Yeah, this is COH. This is also COH.
but it is
Okay.
HO is visible actually. HO, HO single bond and double bond O.
See,
So it is visible.
now you can see the pointer.
Yeah, yes.
This is nothing but the again carbon over here. Correct?
Yeah, yes.
Okay. Now can you see the pointer?
Yeah, yes.
Okay. This is nothing but again the carbon.
Okay.
Okay.
All
This is
junction
C.
we have to consider it is a carbon.
Yeah. Correct. Okay.
Okay.
This is the general representation of your carbon. That is only the chain. Okay. Similarly, if you see here, this is your CH2. Okay. Have you seen my pointer?
Yeah, yes.
This is CH2. This is CH2. This is again OH attached to that CH2. Correct? Two hydroxyls are attached here. Okay.
That
This is,
CH2, right?
yeah, this is nothing but the second requirement of your monomer. Correct?
Where is CH2?
This chain CH2 CH2
You
in
mean
that.
that line is a line of chain is a CH2 only?
Yes.
So any
Junction.
then in that case, the benzene ring, all these line are CH2 only?
No. Due to the presence of C, carbon having four valencies. Okay. Carbon can make four bonds, or it can be having some four molecules attached to it. Okay. Suppose if you are seeing here, see, can you able to see my cursor or pointer
Yeah.
here, red color? Okay.
Yeah.
Here is also one CH2 is there, correct? If you
Yeah.
consider this C only, okay, this C is forming two bonds, correct? One is at this side, one is at this side. Two bonds are there,
Okay.
okay? And these two hydrogens, H2 means two hydrogens. Two hydrogens are attached to it, correct? So that's why carbon is having four valency, means four things carbon can do. Either carbon can form four bonds or can attach four other atoms to it.
Okay.
Okay, correct?
Correct.
Okay. So in similar way, if you consider carbon here in this ring structure, correct? Okay. Can you observe that pointer?
Yeah.
Yeah.
Okay. So it is having one bond at one side and two bonds at other side. Have you observed this? Hello.
Okay, means you that intersection point of that line is a carbon,
Yeah, that
and
is a
that double
carbon,
bond is
and
a,
other side two bonds are there, and at one side one bond is there. Correct?
yeah, three bond we can
Yeah,
say.
three bonds, and again one thing is remaining. So it is nothing but your hydrogen. Means here CH is there. Correct?
Okay,
CH, here also CH, on this side CH, here also CH. Correct? But here at this point, how many bonds are there?
four.
Four. That's why only carbon is there.
Okay.
Okay. Similarly here,
Can
how
can
many
we
bonds?
mention that? Can we mention that also, which you are telling here? Some or already we covered that point.
Which one?
You are mentioning that now at this intersection point CH and carbon is there. Maybe benzene ring formula maybe.
Yeah, benzene is nothing but a C6H6. Only the benzene. It is nothing but the general chemistry will get these things on net as well, because this is like basic chemistry things. Okay.
Basically, what you are explaining that carbon, all this is a benzene formula only.
Yeah, not only benzene formula I'm telling about the carbon only. Carbon having four valencies, it can form four bonds, or four, it can attach to four atoms, other atoms.
Okay.
Okay. I have mentioned it here, but for your reference, I have already mentioned here the detailed structure here, if you observe. Have you observed this structure?
Yeah, this is the same structure which
Yeah, this is the same
carbon.
structure which I have already presented here.
Okay, okay.
Okay. You can consider this instead of this. This is in the reacted form. This is in monomeric form.
Okay.
Okay. So can we move forward? So these are two requirements are here completed. That is two acid functional groups and two alcohol, or you can say hydroxyl functional groups. Okay. So polyethylene terephthalate is nothing but the polymer formed using terephthalic acid is one of the monomer, and second monomer is ethylene glycol. Okay. This ring structure is nothing but your terephthalic acid, and whatever this hydroxyl structure is ethylene glycol. Correct? So as we have observed that this hydroxyl and acid functionality will get react to form your ester linkage. Correct?
Correct.
Okay. This is nothing but your ester linkage over here. Have you observed this? Yes.
Here there is HO is there, so we are calling it as hydroxyl.
Yes. Yes.
Here only one HO is there, but all many carbon are there. That's why we are calling it as carboxyl.
Carboxylic means C. If you observe here, have you observed here?
Yes.
This functionality is nothing but your carboxyl.
Okay.
COOH,
But
complete one. Not only the hydroxyl.
okay.
Carboxylic means C double bond O and single bond OH. This is nothing but your carboxylic structure.
Okay.
Okay. And
But
hydroxyl means only OH.
if H is not there, we call it as ester. If H should be there, to call it as
Yeah, ester means it is connected again to the next molecules.
so hydrogen is connected outside.
Yes.
So
Which come back, which we get off like in sense of water molecule here.
Mhm. So when ester plus one hydrogen, we call it as hydroxyl.
Hydroxyl is nothing but only the OH functional group.
Okay, okay. Carboxyl.
Carboxyl is COOH. Okay.
Okay, okay,
Okay. And the reaction of both, like carboxylic and hydroxyl, will give you the ester linkage. Okay. This is
okay.
nothing but again your ester linkage over here. Can you observe this?
Yeah, yes, yes.
Yes. Okay. So have you understood? Yes. Okay. So this is nothing but the ester linkage. And same repeating unit. Okay. Which repeating unit? From this bracket. Have you observed this bracket?
Yes, sir.
Okay. If you repeat this bracket again and again, your polyester, or you can say PET or polyethylene terephthalate polymer you will get. Okay.
Yes, sir. Okay.
So have you clear about which raw materials have been used for polyethylene terephthalate? that is terephthalic acid, which are having two carboxylic or acid functionality to it, and second is ethylene glycol, correct, which is having two hydroxyl functionality to it. Okay, this is nothing but the monomer requirement for polyethylene terephthalate, and how your polyethylene terephthalate will get formed by reacting these functionalities to it. It will give you the ester linkage here, correct? Okay. So
Yes, sir.
whatever PET polymer you are heard about is formed like this only. Okay. All of you understood?
Yes, sir.
Okay. So we'll move forward. So again, this is nothing but the different type of PETs are available, or different grades of PET available in market, which is dependent upon its processing techniques. Okay, you will see that here, out of which, like if suppose in first you can see here PET or PET, we can call it as, if you are using injection molding or injection blow molding process, or IBM, we can call it as a, so these kind of grades will be used. If you are forming some biaxial oriented films, okay, then OPET, O is stand for oriented, that is biaxially oriented. That's why these kind of grades are available in market. So according to applications, okay, according to different applications, different PET grades or grade of the PET polymer are available in market. Okay, so what all physical properties will PET provide to you?
Sir,
Correct.
one doubt. We
Yes.
studied about stabilized and unstabilized this thing, no? Whether all these are stabilized or unstabilized is also there in the previous slide.
All these are stabilized form.
So, any unstabilized example available?
Unstabilized means whatever the unsaturation is present in your ester or polyester chain. This is nothing but your whatever the unsaturation, that is unstable form, correct?
Is it like a defect?
It's not like defect. In general terms, it means someone called it as a defect because some reaction will take place over it. Okay, that's why someone can call it as a defect, but it is not a defect. It is just a reaction site on your polymeric chain.
Unsaturated in market we don't have currently. It's like that, huh?
Yeah, currently we are having unsaturated polymers or unsaturated resins in market, but that generally used for coating applications, or you can say paint applications.
Okay, okay, sir.
Okay, that we will study further. I have added that part as well. Okay.
Okay.
Okay. So what all properties PET plastic is having? Okay, so very first property is that it has an excellent level of wear resistance compared to other plastics. Okay, it is having some like hard nature, correct? PET, if you observe. Okay, so it is having excellent wear resistance. Okay, it has a high flexural modulus, making it flexible. If you see, many of the packaging things are made up of PET, like water bottles, which are flexible, correct? Then if you see food packagings, that in many food packagings, PET have been used, okay, due to this flexural property. Okay, then it has a superior level of stability, making it versatile and strong. In application, if you see the application of PET, it is having much stable polymer, correct? We can store water in it for a longer time. We can store food, correct? So that stability it is having. Then again, it has a low coefficient of friction, making it useful in various applications in which other plastics are not. Okay, the plastic chemicals do not leak into the fluid or food stored within it making. Okay, one of the most important products for food storage, as I have already mentioned, many of your food storage packets, or you can say containers, are made up of your PET plastic. Okay, so these are nothing but the major properties of your PET, which is nothing but polyethylene terephthalate. Yes.
Here it's mentioned mechanical properties up to 150, 175.
Yes.
So
So
if I
it is,
put boiled water in the PET bottle, nothing will happen in my.
yeah, it is like not a not in a PET bottle, I am telling here. PET characteristics. What exact characteristics? Because of higher melting. It is having melting point nearly 250 to 256 degrees Celsius and glass transition temperature about 80 degrees Celsius. Correct?
Yes,
Glass transition temperature is nothing but the temperature above which your plastic will behave as a or start to get flexible.
right.
Okay? If you heat it, if you heat a polymer at one point, it will get flexible. Correct? So
Right.
that is nothing but your glass transition temperature. Okay.
Yeah.
So temperature retains good mechanical properties up to 150 to 170 degrees Celsius. As its melting point is 252, 252 to 256. So before that, one at 150 degrees Celsius, it is showing or it can retain the mechanical properties. Okay.
So okay. Means if we put boiled water in the bottle, nothing will happen, right?
No, it's not always the case, but if you boiled water means it is nothing but 100 degrees Celsius. And thickness of your bottle, if you consider, you can consider the normal PET bottles or packaged drinking water, you can consider what thickness it is having. It is having very much lower thickness, correct?
Yeah.
As it is having glass transition temperature 80 degrees Celsius, above
Hardly
80 degrees
point 0.5,
Celsius,
hardly point 0.5 maybe.
okay? Yeah, hardly less than that actually.
Okay.
Okay. If you consider like above 80 degrees Celsius, it will get flexible or it will reshape. So if you insert 100 degrees Celsius like boiling water on 90-95 degrees Celsius water, so obviously it will reshape or it will collapse its shape. Okay. But it will not degrade or it will not melt at that temperature. Okay. This temperature, whatever the mechanical properties, it is for higher or you can say for high thickness applications. Okay.
Okay.
So next is like where at what all applications polyethylene terephthalate we can use. Okay, as I have already mentioned at the start of this lecture. Okay, at what applications we can use the polyester or not means I have majorly said like polyester only, but specifically polyethylene terephthalate or PET at what applications we can use. So very first application is nothing but your plastic bottles, correct? Have you observed here plastic bottles? Or you can say any drinking means packaged water bottles that are made up of your polyethylene terephthalate or PET. Okay. Can we take 2 minutes break?
Yeah.
Yes, sir.
Definitely.
Okay. So we'll again restart after 2 minutes. Okay.
Great.
Hello,
Yes.
all of you are there?
Yes.
Yes, sir.
Okay, that's great. So we'll again continue the lecture. Okay. So we are at the point where we are discussing the applications of PET, or we can call it as a polyethylene terephthalate. Okay. Very first application is drinking water or packaged water, you can say. Okay. Which we can observe at railway stations and many of the shops. Okay. Have you observed that bottles before? Hello.
Yes.
Yes, sir. We have
Yeah.
observed.
That are nothing but made up of your polyethylene terephthalate. Okay. So second application, its high mechanical strength make polyethylene terephthalate film ideal for tape applications. Whatever we can call it as a tapes we use to stick the things that are made of again that polymeric things. That polymer sheet is made up of your polyethylene terephthalate or PET again. Then non-oriented PET sheets can be thermoformed to make packaging trays and blisters. Okay, have you observed any trays, or you can say if you order some food, okay, if you have ordered some food, then it will come in some plastic container, correct? Yes.
Yeah.
Yeah, that plastic container is nothing but made up of your PET polymer again. Okay, it is nothing but the made by using thermoforming process. Okay, so
Which plastic container, please?
whatever food you have ordered, or if you suppose some mm, you have bought some food or some fruit items from market. Nowadays packaged you can say packaged fruits are there. Have you observed these images over here?
Okay.
Have you observed these plastic containers?
Generally we're getting a biryani that
Yeah,
in
correct.
PP
What?
material only I observed. Maybe
PP?
or okay, I didn't notice,
No,
but
no, no.
it is a white
That
kind
is
of a
that is that
strong.
is made up of your PET, polyethylene
Okay, maybe I
terephthalate.
will
No
maybe
one
I will
will
check
use
the
PP in
marking
that
maybe.
case.
Okay.
If someone is using PP, that will having somewhat high cost, and some other things are also there. But generally, PET containers they are using. Okay.
But PP we can also use that as a that container, right?
Yeah, but none of the like if you observe some tiffin boxes,
Yeah.
okay, your tiffin boxes, if you observe that sealed boxes, correct,
Mm-hmm.
that made up of your PP, that are for long term use. Okay,
Yeah, got it.
but whatever the food orders or food delivery orders are there, that are not for long use purpose, that are for short use purpose, that are made up of your polyethylene terephthalate.
Okay.
Okay, then again some food packaging, as I already told you, this is nothing but a food packaging. Then other packaging applications included cosmetic jars, microwavable containers, then transparent films. Okay, many of the packagings, or have you seen any packaging on your fruits? If you are buying some apples from some malls, correct, they have some plastic packaging on it, correct, which is having like airtight packaging is there, correct,
Correct.
on your fruits or apples. That packaging is nothing but again your paid packaging. Okay, some transparent films or films were there, correct. So that is nothing but your paid packaging. Okay. The daily life use or everyday life use of PET is like we have already mentioned. Okay. This is nothing but the this is again the repeatable things like soda bottles, bakery products, or you can say water bottles, peanut butter jars, or frozen food packaging. As I already told, some frozen means food packagings are there. Then secondly, like cosmetics. Okay, manufacturers can create a specific shapes of for various cosmetic products like bottles and all. Okay, then storage of chemicals or storage of household cleaners, whatever the cleaning liquids we are using for cleaning the clothes, or you can say cleaning the marbles and all. For that, cleaning liquids are means stored in your PET bottles itself. Okay,
Like choline, right?
yeah, choline, correct, choline. So
But
there are some
can we
add.
move to backslide? Can we go to backslide?
Yes.
Why we categorize into three boxes? Just
Yeah, it is not a categorized. Don't worry, it is not a categorized. It is just a flow of applications.
Okay. Based
Yes.
on three application. Okay, got
Yeah,
it.
yeah. Majorly, PET is in daily life. If you observe in daily life, PET is generally used for packaging purpose only. But if you see some major applications, in major applications, PET are being used for differently. But these all are like your daily life applications. Okay.
But packaging purpose, for example,
Packaging means whatever I have just now explained, like food packaging,
or water
or you
bottle.
can say that whatever the containers we are using for food, that is nothing but a
Okay.
packaging again. Correct.
But
Water bottles.
mainly we see that water bottle only.
Yeah, yeah, yeah. That water bottle is nothing but the packaging. This is nothing but the packaging of your water. Correct.
Okay.
Yeah. So there are some advantages and disadvantages for your PET plastic. Okay. First of all, we will see the advantages of it. PET passes a high strain to weight ratio, thus easy and inexpensive to transport. Okay. Means in short, your PET, water PET plastic is there, that is lightweight. Okay. Due to its density difference and all, the PET is lightweight plastic. That's why it is generally used for packaging, which is easy to transport. Okay. Second is like it is available in abundance and it is inexpensive compared to other thermoplastics. Now only I have mentioned like if you use polypropylene containers, then it will have some more cost to it than your PET. That's why generally we are using PET for food packaging, or you can say daily whatever the short-term food packagings are there, we are using this PET. Okay, it is moisture sensitive. Okay, then it shows fantastic electrical insulating properties. It is also used as a insulation properties for your electrical appliances. Okay, then what all disadvantages are there for PET? Okay, one by one we will see PET is not biodegradable. Obviously, it is made from petroleum sources, like whatever the raw materials we are using, it is nothing but a petroleum sources and polymer. It is nothing but a synthetic polymer. That's why it is not a biodegradable one. Okay, PET is somewhat vulnerable to oxidation, but nothing is rock solid proof about these. Means generally, I think you have heard like whatever drinking bottles or drinking water bottles are there, some people are saying like some of the chemicals are come out of the bottle and mixed in your water. That's why your water taste will get changed. Have you heard this before?
No.
Okay. So generally people are making like things in that way that due to the chemical properties of your PET, some of the chemicals are liberated in water during the storage. That's why. But it is not happening generally. Okay, if some like some conditions are applied, some suppose extra heat has been applied to it, then some aldehyde or something chemical moiety will get released in that way. But in normal packaging, it will not happen. Okay, that's why some rock solid proof about this is not there for now. Okay, but it tends to oxidation. Okay, this is this is a sample. Sorry. Okay, these are nothing but the disadvantages for your pet. Okay, so now in same we are looking two types of polyesters. One is saturated and second is unsaturated. In saturated itself, second example is PBT, or we can call it as a polybutylene terephthalate. Okay, hello.
Yes,
Yes.
sir.
Okay, so what is the basic difference in both of these polymers? Both are polyesters. Okay, PT and PBT. Have you heard PBT short form before?
Yeah.
Yeah.
In which application?
Generally, I observed in electrical application
Yes,
and maybe some fasteners.
yes,
Yeah.
correct, correct. So PBT is nothing but a kind of polyester again. Okay, it is generally formed using, now we can apply the requirements to form polyesters. Okay, here are also two monomers are there. Okay, Have you observed two monomers?
Yeah, butylene glycol and
Yeah, butylene
terephthalate acid.
glycol and terephthalate acid. Correct. This terephthalate acid, we again repeated this monomer. Correct. In PET as well, we have seen terephthalate. Correct.
Okay. That terephthalate is repeating in PET and PBT both. Yeah.
Okay.
And
In
why
PET
why you are
as
telling
well.
that glycol, this butylene glycol? Why we
Yeah,
are glycol?
that we will see. Okay.
Okay. Due to OH or no? It's no.
Just give me a minute. Okay. So if you observe here, how many carbons are present over here?
4.
Four. Correct. Four carbon chain is there. Okay. And if you observe the thing in ethylene glycol, correct. In ethylene glycol, two carbons are there. Correct. Two carbon chain is there. Okay.
Yeah.
So if you are having two carbon chain, then it is ethylene. If you are having three carbon chain, then it is propylene. And if you are having four carbon chain, it is butylene. Okay. That only difference is there between your PET and PBT structure. Okay. Why it is called as the butylene glycol? Because it is having four carbon chain,
Okay.
correct? CH2,
Correct.
CH2, 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 four carbon chain and two hydroxyls at the end. That's why glycol.
Okay.
Okay. This is nothing but your butylene glycol. And this terephthalate acid is having same structure as we have used before in case of polyethylene terephthalate, correct?
Correct.
The reaction is same. Whatever the acid or carboxylic functional group is here will get react with this hydroxyl functionality, correct?
Correct.
What it will form? What is this?
Polybutylene terephthalate. This is
Which linkage is this?
COO. Acidic acidic linkage.
The class of plastic itself suggests you the linkage. Which class of plastic this is?
That
What is the lecture of this name?
polyester.
PBT.
Polyester.
Polyester.
Ester.
Yeah. So this is nothing but your ester linkage by reacting your acid with hydroxyl.
Right.
Correct. Acid with hydroxyl will get react and you will get the ester linkage over here. Correct. So
Yeah.
this is nothing but again the class of polyester.
Basically,
Okay.
there are in this there are two ester linkage, right?
Yeah. In previous case as well, if you see here you can observe two ester linkages over here. One at this side, one is here.
Right.
Have you observed?
Yeah.
In one repeating unit, if you consider one repeating unit, you will have two ester linkages. Correct.
Got it.
In this as well, if you see one repeating unit means the present in which is present in the bracket. Correct.
Got
In
it.
bracket, this one and this one. Okay. And water molecule will get released. Correct.
Correct.
Have you got the reaction for polybutylene terephthalate? Hello.
Yeah.
Yes, sir.
Okay, correct. So polybutylene terephthalate is a widely used thermoplastic engineering material and the member of polyester family of polymers, as I have already mentioned before. The main application of PBT in the electrical and electronic industry due to its very good electrical resistance, toughness, and surface finish. Correct. One of you have mentioned the applications of PBT.
Yeah.
Correct.
Electrical. Yeah. I also
Electrical.
in that PBT that electrical cover like
Yes.
ECU
Correct.
cover kind of. Yeah.
Yes, that is made up of your PBT. Many other polymers are also there, which are showing the electrical property, means good electrical resistance. Correct. But for now, we are studying PBT. So PBT is using for electrical resistance application. Correct. When treated with
About
flame, yes.
what about any apart from electrical, any other
Yeah,
automotive?
one by one we will see that. That's why
Okay.
that are there in your next lectures,
Sure.
upcoming lectures. Okay. When treated with flame retardant, it become inflammable, resistance to chemical and water makes. Means it is a flame retardant polymer. Means it retards the flame. Okay. Have you understand the retardation of flame? Means if you
Yeah.
are burning the thing like PBT, It is not like a fully burning. Okay, obviously all many of the polymers will get burned, but it will just retard the flame. Okay, it is also having resistance to many of the chemicals and water. Okay, make it very useful for packaging purpose as well. Okay, as we have already observed that it is produced by polycondensation of terephthalic acid and butylene glycol, or we can also call it as a 1,4-butanediol. Okay, both the names are same or for same compound. Okay, raw materials we have already discussed. Okay, the melting point of it is like 232 degrees Celsius. Okay,
Yeah.
there is chief application in industrial field or field of industrial plastic. Lately, it has also been used to manufacture carpet yarns and textile fibers. Okay, as polyesters having application in fibers. Okay, the base resin is widely used in compounding. Okay, as a good chemical and heat resistance, as we have already mentioned electrical properties and all. Okay, so all of you know about the polybutylene terephthalate now.
And I think this is also physically when we'll see that part, it is having self lubrication property, right?
Ha, correct. Many of the times your PBT means not in all applications, but in gear applications they have been used, okay, due to the
Yes.
lubrication
And
property.
also that I observed in the interior that clips all are PBT. If you are a nylon and PBT also both are using. So it is helping for easy assembly also due to self lubrication property maybe.
Yes, nylon is majorly used for the gear application due to
Yeah.
self lubrication property. Okay.
Okay, nylon also
I think you have
nylon
studied
also
nylon in your previous
self
lectures.
lubrication property. You mean to say?
Self lubrication is for gears. In if you see many of the industrial applications or in many of the machines, you can observe the plastic material which generally used for the gears.
So we can say that if I talk about lubrication property, both nylon and PBT having lubrication property.
Yes, but more in that case, more lubrication properties having with your nylon than your PBT.
Okay.
Okay, I think
Are you sure?
nylon part you
I
have
thought
studied
PBT is
before.
more that lubrication. I thought.
Yeah, but in many of the gear applications, if you see, many of the gears are made up of your nylon.
Okay. I mean, maybe that means a different reason, but lubricating point
Yeah.
of view, currently my thought is PBT is more compared to nylon. Maybe you can recorrect.
Okay. We'll see it again.
Okay.
Okay.
Yeah.
So I think you have already studied about the nylon part in polyamide section. Have you studied it? I think in last four
Yeah,
to
yeah.
five
We
lectures.
studied last
Yeah.
class. Yeah, that ma'am has taken. Yeah.
Okay. So I think I have already mentioned the difference between polyester and polyamide in later on slides. In that, we will correct that thing what you told to me. Okay.
Okay.
Okay. So these are some advantages and disadvantages of polybutylene. Okay. So polybutylene terephthalate. It is having high continuous use temperature up to 150 degrees Celsius, as it is its melting point is 230 degrees Celsius, as we have seen in last slide. Okay, very good creep resistance even at higher temperature, high rigidity. It is having good frictional properties and wear resistance. Okay, good frictional properties means again as we have mentioned like self lubricating, correct? High dimensional and UV stability. UV stability means in UV rays it will not deteriorate fast. Okay, that's why UV stability is there. Good weather resistance, resistance to cracking from environmental strains. Yes, yes. Okay. Low water absorption, or you can say moisture. It is having moisture resistance. Okay. Then again, if you see the same disadvantages is here, notch impact strength is low. Okay. Then poor resistance to hydrolysis. Whatever the hydrolysis part is there, okay, in presence of some heat and moisture, it will get hydrolyzed. Susceptible to halogenated hydrocarbons corrosion. Okay. They having tendency to warp when reinforced with glass fiber. Okay. Lower glass transition temperature. compared to high grade plastics. Okay, if you consider it with some high grade plastics, it is having low glass transition temperature, as we have observed in case of polyethylene terephthalate. It is having 80 degrees Celsius the glass transition temperature. So if in many of the tough applications we can't use it after, or you can say 70 to 80 degrees Celsius. Before that we have to use. Okay. So again, if you observe the applications of polybutylene terephthalate, electric connectors, okay, then smart network interface devices, then power plugs and electrical components, as someone has mentioned already, power plugs, switches and controls, then breaker enclosures, as someone have mentioned that the covers of some electrical circuits are made up of polybutylene terephthalate. Then outdoor telecommunication enclosures, automotive under hood components, okay, electrical appliances components, fiber optic tubes, medical applications such as clamps, pump parts, and plugs. Okay, these all are nothing but the applications of your polybutylene terephthalate. Okay,
Yes, sir.
so other than these polyethylene terephthalate and polybutylene terephthalate, what other things are there in your polyester family? Okay, we have observed some. Just give me 1 minute. Some ribbon is coming over here. Okay, so here are some examples of polyesters. Okay, at the very left side where my cursor is there, or you can say pointer is there, you will observe the examples. Okay, like here I have mentioned like polyglycolide, or you can say polyglycolic acid. Okay, this is nothing but the example of polyester. Again, I have mentioned the names only here. Okay, polylactic acid, polycaprolactam, polyethylene adipate, polyhydroxyl canoate. Correct. These all are nothing but the aliphatic. Aliphatic means only the chain structure is there. Okay. Then semi-aromatic form, which is nothing but the polyethylene terephthalate. Semi-aromatic means some ring structure is there. Correct. In your polyethylene terephthalate and polybutylene terephthalate, your terephthalic acid having ring structure to it. Correct. Hello. Hello.
Yes, sir. Yes, sir.
Okay. So that ring structure and whatever the glycol we have used, like ethylene glycol or butylene glycol, it is having a chain structure. That's why we called it as a semi-aromatic polymers. Okay. In that polyethylene terephthalate is there, polybutylene terephthalate, then polytriethylene terephthalate, polyethylene naphthalate. Okay. Then in fully aromatic, Vectran is an polyester which is available over there. Correct. So out of these, some of the polyesters means many of the polymers are formed using your synthetic raw materials, or you can say petroleum based raw materials. Okay, so many of the polyesters are formed using bio based sources, or you can say biopolymers. Have you heard that word biopolymer before?
Yeah, biopolymer.
No,
Yeah.
sir.
Yeah, where you observe that word?
That some discussion happened, but I unable to connect the dot. But yeah, I'm aware that some biopolymer are there. That's
Yeah,
right.
biopolymers are there. The biopolymers are nothing but whatever polymer you are going to synthesize, or whatever polymer you are going to make, it is fully from your bioresources. Or you can say environmental resources. Okay, so these are nothing but your biopolymers. So there are some polyesters, means polyester class having biopolymers in it, which we called it as a polylactic acid or PLA you have heard before. Many of the industries or many of the sustainable industries are now talking about PLA, correct? Polylactic acid or polyglycolide. I have mentioned some of the examples over here for your understanding. Okay, these are nothing but the biopolymers under the class of family like polyesters. Okay, so we have studied 2 to 3 examples of saturated polyester class. Okay, here I have given some more examples of polyesters. Okay, can you see that?
Yes, sir.
Yeah, these all are nothing but your class of, or you can say family of polyesters, in which if you see polyethylene succinate, polybutylene adipate, terephthalate, or you can say where you have mentioned already, talked about polyethylene terephthalate, polybutylene terephthalate. Okay, as I have mentioned one biopolymer example, which is nothing but a polylactic acid. This is second last. You can observe here. Correct. So these all are nothing but the examples of your polyester, or you can say saturated polyester. Okay,
But uh, but here it mentioned PET.
PET is not there.
We mentioned PET, right?
No. PET I have mentioned here for your example purpose only. Generally, see, if you see some plastic article, correct,
Yeah.
over it some number have been written over there. Have you observed that?
Yeah, marking, some marking, yeah.
Yeah, marking. So this kind of marking you can observe on many of the virgin polymeric materials, you can say, not compounded, not mixture of two polymers, virgin polymer, only one polymer, single polymer use. Okay. Over there, you will observe this kind of symbol.
Why? What is the
Okay.
reason?
Yeah. So this is nothing but for to identification of your polymer, means easy identification of polymeric material. Okay.
But why
So
when one is mentioned, when one or that?
one is generally mentioned for PET, polyethylene terephthalate. This is, see, just listen first what I am saying. Okay.
Okay.
This is the general representation for daily use, or you can say the plastics which we generally use in daily life. Okay, there are only 6 identification numbers, 1 to 6, 1 2 3 4 5 6 are present in this way. Okay, which are like for each and every polymer the number is not there, only the daily use plastics. Okay, which all plastics we daily use, like polyethylene terephthalate, polystyrene, polyethylene, polypropylene, correct? LDP, HDP, in that way.
All having same symbol,
Symbol is same, but the number is different.
different. Because I can observe it's green and arrow, so maybe recycle they want to
Yeah.
well
See,
virtually maybe.
why this number is given? If suppose means many of the thermoplastics have been recycled, or they can be reused, correct? By remolding it.
Yeah.
Okay. That's why to segregate the plastics, okay, to segregate the general plastics, these symbols have been mentioned over there. If I suppose give you some uh, 20 to 50 plastic bottles, okay, so how we will segregate it by the type of plastic?
Got it. Got it. By symbol only marking.
Okay, so in each of the, means this is the standard one. If you have some local bottles, then may not be, they may not be mentioned the symbol, because they are using some mixture plastics in there. Okay, so
And
generally six no, till 6 number symbols are there. So for one number, PET is there. Okay. Other you can search out on net, you will easily get it. Okay.
okay, this is the PET comes under polyester, and also on right
Polyester,
side that
polyester.
red and polyester, yeah. That right side, that red one and blue one, all these are part of polyester only type of,
Yes. All these examples are of polysters.
including PET also.
Yeah, including PET.
Okay.
Okay. So we'll move forward for some, and some, just give me 1 minute. Okay. So polyester having many applications as we have seen till now. Okay, but again, if you see, we have not discussed about the polyester fabrics, or we already mentioned like polyester is used as a fabric application, one of the major application in fabric. Okay, many of the polyester fabrics have been there in market. Okay, so this is nothing but one of the example like fabric made out of the polyester. Okay, so here some of the properties. Okay, polyester fabrics are strong in nature, they are lightweight, elastic in nature. Okay, you have observed any stretchable fibers in market. Okay, many of that are made up of your polyester. It has a durability, easy care, it has abrasion resistance. Okay, it has a washability, you can say it can be easily washed out. Okay, there are two type of fabrics generally available in market, which are like polycot and polywool. Okay, polycot is nothing but the mixture of your polyester and cotton. Many of the stores are saying that this is the like, if you visit the market and if you buy some shirt or something, then they are saying like this is the pure cotton, this is in that way. But if you observe, many of the fabrics are made up of mixture, that is polyester and cotton mixture, or you can say polywools, which is nothing but a mixture of your polyester and wool. Okay, hello.
Yeah.
Hello.
Yes, sir.
Yeah. So the second class is like nothing but unsaturated polyester resins. Okay. Hello.
Yes, please.
First is
Yes,
already
sir.
we have seen like saturated polyesters, which are nothing but your polyethylene terephthalate or PET, PBT in that way. So I have already discussed the saturated and unsaturated part. Here, if you observe, I have highlighted by yellow color. This is nothing but the CH double bond CH, correct? This is
Correct.
nothing but the unsaturation part of your structure. Okay. Previously, we have observed in these structures, if you see the bonding over here, CH2 single bond, CH2 single bond, all of the bonding is present in a single bonding way, correct? This is nothing but your saturated. Okay. And if you observe here unsaturated part, you will see here double bond is there, correct?
Mm. Okay, you meant a single bond, then that saturated, a double bond.
Means whatever the single bonding is present in your polymeric chain, polymeric repeating unit or polymeric repeating chain, carbon carbon single bond I'm talking about.
Okay.
Okay, that is nothing but your saturation part or saturated part. And if you are observing carbon carbon double bond, see, remember carbon carbon double bond. Okay, that is your unsaturation.
Why it will become unsaturation due to carbon carbon double bond?
Yeah. Okay, I will tell you. So in case of saturated polyesters, we have used two kind of monomers. One is your diacid, or you can say dicarboxylic acid, correct? And one is your diol,
Yeah.
correct? If suppose in some applications your further reactions are required or further modifications are required. Okay. Suppose now if I want to have some polyester coating or paint, okay. So paint will be in form of, suppose if you are having some like have you observed any coating in market which are available in two containers? Like some of the, if you observe like some of the people are taking some resin from one container, and so in second container some liquid is adding to it and mixed it and apply it. Have you observed that?
Sorry, come
Yes,
again.
sir.
Different.
Okay.
Liquid.
Simple example you can take like epoxy resin. Have you seen epoxy resin?
Polyepoxy resin. Yeah,
Yeah, yeah.
I have. I think we are using in the SMC, compression molding.
Okay. So have you adding something to epoxy?
Uh, yeah,
You
yeah.
can you can call it
That
as
is
a
a
hardener or cross linker in that way.
um, Partner, no, that okay. I'm talking about SMC. That it is a combination of polyepoxy resin
Okay, that is
plus
already
plus glass
already
fiber
formed.
plus glass
Yeah, yeah,
fiber.
yeah. That sheet is already formed. That is already cross-linked. Okay, I'm talking about poly means whatever the epoxy resin. Okay, if you see in market or anywhere, you will get epoxy resin in a liquid form or in a viscous form.
Or maybe you are
Okay,
talking about like hand layup FRP process, right? Kind of. Then
yeah, in hand layup as well.
yeah,
Okay,
we are
hand
adding
layup.
some hardener so that it
Yeah,
is
that
hard.
hardener is nothing but your yeah. So in that also some reacting sites have been present in your polymeric system. Whatever the liquid resins are there, okay, whatever the liquid resins are there, some reacting sites are already there. Okay, that reacting sites are cross-linked your polymeric chains with each other. Okay, previously if you see all resins are in form of liquid, correct? After application, as you are mentioning here, hand layup, correct?
Yeah, yeah.
Correct?
FRP hand layup process here.
Yeah, FRP hand layup process. In that, previously means whenever you started the process, your resin is in a liquid form, correct?
Correct, correct.
But after forming the article, that article will be in a solid form,
Yeah.
correct?
Curing time will take approx 2.5 hours.
Yeah, curing time.
Yeah.
So in that curing time, this unsaturation, whatever the unsaturation is there, that will break and it will attach to the second chain or second polymeric chain, you can say. Okay, that's why the unsaturation is there. Okay, so this is just a simple example that we will discuss further. I have already added that cross-linking or hardening part in upcoming slides. Okay. So polyesters or unsaturated polyesters are nothing but a low molecular weight polyesters derived from unsaturated diabasic acids or anhydride. Unsaturated diabasic acids. Okay. If you see here, ester linkage is there, correct? This ester linkage will form using acid functionality or carboxylic acid functionality, correct?
Yeah.
Okay. So whatever the structure of this acid, if you consider this structure, can you observe this? Just a minute, I will try to highlight this. Okay. Can you consider this structure?
Yes, sir.
Okay. This is before reaction. This is nothing but your carboxylic structure. Okay. Carboxylic acid structure in which this unsaturation is present over there. Okay. This structure is nothing but your unsaturated diabasic acids. Okay. Which dissolved in unsaturated vinyl monomers comprise a versatile family of thermosetting materials, which called it as a thermosetting. Correct. Whatever saturated polymers we have studied before, all of them are like thermoplastics. Correct?
You mean to say all saturated are
Many
thermoplastic
means
only?
majorly you can say.
Clearly. Okay.
Okay, majorly all of the, not all of the, but majorly polyesters or saturated polyesters are nothing but your thermoplastic family. Okay, what
And
are the unsaturated polyesters are there that are of your thermosetting?
or vice versa, all thermoplastic are saturated
Yeah, majorly.
majorly. Okay.
Okay, so all thermosetting materials known generally as a unsaturated polyester resins. Okay. So what is the major difference between your saturated polyester resin and unsaturated polyester resin? Or you can say saturated polyester polymers and unsaturated polyester polymers. Okay. So one by one we will see. Saturated polyester resin is a type of synthetic resin formed through the condensation polymerization of saturated diols with saturated dicarboxylic acids. Correct? This is nothing but the requirement to forming the saturated polyester resins, which we already studied. Which two requirements are there? Saturated diols. Diols means your two hydroxyl groups at the end, correct?
Yeah.
And saturated dicarboxylic acid. Dicarboxylic acid means two carboxylic functional groups or carboxylic acid functional groups at the end, correct? This is the basic requirement of your saturated polyester resins, correct? And for unsaturated polyester resins is a type of synthetic resin formed through the condensation polymerization of unsaturated diols with unsaturated dicarboxylic acid. Whatever I have rounded here with red color, it is nothing but unsaturated dicarboxylic acid, correct? In your dicarboxylic acid, this unsaturated part is there. Have you observed this?
Yeah, double bond.
Yeah, this is nothing but a requirement for your unsaturated polyester. Okay, this is the first difference. Second is like formed through the condensation polymerization of saturated diols. Obviously, this is again the repeated thing. Okay, the examples are like ethylene glycol, propylene glycol, butylene glycol, as we have used in PBT, polybutylene terephthalate, we have used butylene glycol. Then saturated carboxylic acid examples are like phthalic anhydride, isophthalic acid, or adipic acid. Okay, this adipic example we will see in further slides. Okay. Then what is the requirement for unsaturated? We already studied that unsaturated dicarboxylic acid and unsaturated diols. Okay. Then the third major difference is like the chemical structure does not contain any double bond or unsaturated groups into it. Correct? For saturated polyester resin. Correct? If you see in unsaturated, the chemical structure contains unsaturated double bonds located between the carbon atoms in the main chain of the polymer. Correct? We already seen the difference here. Correct?
Yes, sir.
Yeah. So have you understand this part? What is unsaturated polyester and what is saturated polyester? Have you
Yeah, the
understand?
major difference is the double bond.
Yeah, correct. Double bond between your carbon chain,
Yeah.
carbon. Okay. We'll move to next slide. Okay. Here are the list for your unsaturated polyester resin synthesis.
If the input is unsaturated, the output is also unsaturated in this case.
Yes.
So wherever there is a input of both um, uh,
Saturated and saturated.
acid group and that monomer group, both these two are unsaturated, no? Then the output is also
Yes.
okay.
Yes.
Okay, sir.
So these all are nothing but the raw materials which generally used to synthesize or to prepare the unsaturated polyester resins. Okay, name wise I have written here. Structure wise we will see in next slide. Okay, what all raw materials we can use over here. Okay, so here you can observe first of all the in very left side of my slide you can observe here the unsaturated polyester resin. Okay, the requirement as we have mentioned here, suppose if you take the example of itaconic acid. Okay, itaconic acid is nothing but having the two carboxylic acid functional groups. Have you observed here carboxylic functional group?
Yeah.
Okay, on this side as well, correct? And one unsaturation is present here. Have you observed this?
Double bond.
Okay, so this is nothing but the unsaturation present. So this is the requirement for your unsaturated polyester resins. Okay, this diacid will get react with this diol. Okay, will give you the polyester. Have you observed here polyester? This is the ester linkage, correct? And this is the unsaturation present in your structure. Have you seen this unsaturation? Okay.
Yes.
Sir. Okay, sir.
Yes. So now whatever the hardening or curing, okay, as I have mentioned before, all of the unsaturated polyester resins undergo hardening, or you can say curing, as someone have mentioned some hand layup process, correct?
Yeah.
So curing will be there. Okay. So what happened in that curing process? Okay, here I have mentioned one unsaturated polyester over here. Have you seen this green part?
Yes, sir.
Okay, so unsaturation is present here. Have you seen this C double bond C?
Yes, sir.
Okay, so this is nothing but the unsaturation present in your polymeric chain. Okay, now we will take suppose some two polymeric chains here. Okay, one by one. Okay, so we have take vinyl or vinyl styrene as a cross linker or hardener, you can say. Okay, what that hardener will do, that hardener will connect your two chains by reacting their unsaturation part. Okay, have you observed this highlighted part? Hello, hello.
Yes, sir.
Okay, can you observe this highlighted part here? Whatever the vinyl styrene hardener they have took, they will break the unsaturation or break the single bond, which is extra single bond over here, means double bond. Okay, that double bond will get break and that will attach here, correct? So this is nothing but you can say the cross linking of two polymeric chain with the cross linker. Have you observed this?
Yes, sir.
Yeah, in the very representative way I have mentioned over here, some polymeric chains are there. Okay, that polymeric chains will get connected by this cross linker. Okay, this cross linker will cross link your polymeric chains. Okay, after cross linking your polymeric resin will get hard. Okay, this is nothing
Okay,
but
sir.
the hardening or cross linking process of the unsaturated polyesters. Okay, all of you
Yes, sir.
understood this? Okay, next is like the characteristics or properties of the unsaturated polyester resins. We'll see one by one. The main features of the unsaturated polyester resins include the liquid, that is it is having in the form of liquid in their use. Okay, poor linear shrinkage, that is excellent with wettability of the fiber and charges. Okay, excellent wettability means whatever the layup process you have mentioned here, whatever the layup application you have mentioned here, you have mentioned like glass fibers are being presented there, correct?
Yeah,
Glass fibers
basically,
have been introduced over there, correct?
yeah, glass roving, we are making a layer.
Correct, that glass fibers are nothing but the, here I have mentioned that wettability of fibers, correct? Suppose if you are having polyester resin with you or unsaturated polyester resin and you are adding fibers to it, correct? So that fibers will get wetted or that will get mixed very nicely. That is the major property of your unsaturated polyester resin, that excellent wettability of your fibers. Okay, then cold cross linking by addition of hardener. Okay, whatever layup process is there, in many of the cases at room temperature they will get cure or they will get hardened, or in many of the cases they require some stoving or some temperature to get hard. Okay, so in your case what do you observe? They are providing some heat to it or they are hardening it at room temperature? Hello,
That room temperature only.
room temperature only. So there might be they are using some unsaturated polyester resin, might be, yeah? Because many of other resins have been used for that layup process. Okay, but for in case of unsaturated polyester resin, it can be hardened at room temperature. Okay, minimization of the effect of sagging in vertical stratification. Okay, then it gets solid after cross linking, correct? Obviously after hardening it will get solid. Rigidity is there, good electrical insulation properties there, dimensional stability against temperature changes, then higher strength to weight ratio as we have observed in case of saturated polyester as well. Okay, excellent surface finish, water repellence is there due to hardening, resistance to wear and high temperatures, and it is having good mechanical resistance. Okay, these all properties your unsaturated polyester will give after hardening. Okay,
Okay, sir.
so next is like which all applications are there for unsaturated polyester resins. Okay, we have already studied the application of saturated polysters. Okay, which all are that for saturated polysters? Hello, which all applications are there for saturated polysters we have seen?
Pet bottles, food packagings.
Yeah. Packaging, food bottles, food packaging. Okay. Here you can see the applications of unsaturated polysters are nothing but the wood paints. As I have already mentioned, unsaturated polyester resin is used for coating or paint applications. Okay. Over here you can observe wood coatings or wood paint, correct? Then flat laminate panels or corrugated panels, reed panels. What are the panels you have observed here? Or whatever you have mentioned now, the layup, hand layup, correct? Whatever the whatever the boat or whatever the is making or the hulls of the boat that are nothing but the many means small boats I'm talking about that are made up of that hand layup process. Many of the
Right, right.
corrugated panels, in which application you are using that hand layup?
Generally, that we have seen that many parts, boat or we can say
Yeah,
that uh,
cooler.
cooler or that playing toy, that
Okay.
park, jhula, all this,
Yes,
and
correct. In many of the chair applications, but previously it was there in chair applications. Nowadays chair applications are out of your
yeah,
thermoplastics.
bus body also that hand layup generally,
Yes, correct,
because
correct.
generally it's not
So
required to
in that also your unsaturated polyester resins have been used in many of the applications. Okay.
okay.
Then
And
gel.
what about hardening? Are we adding hardening in both
Yes. Obviously,
saturated and unsaturated
we are
both?
adding hardener in that case.
Saturated and unsaturated both?
No. In case of unsaturated resins only.
Okay, so you mean to the all unsaturated resin we are adding hardening only.
Yes.
Okay.
Okay. Then coloring pastes, fillers, putties, and chemical anchorings. Then self-extinguishing composite materials. Whatever the hand layup materials you are using, that is self-extinguishing only. Okay. Quartz, marble, and artificial cement. Okay. That are made up of your unsaturated polyester resins.
Basically, that hand layup we are using where we need a strength like sheet metal and
Yeah. That's
moldability.
why you are using some glass fibers in that.
Yeah,
That glass
moldability
fibers will
like
provide
plastic.
you the
Yeah.
strength.
So generally, the tool investment not required kind of a like injection molding, so cost effective capex kind of, yeah,
Yes.
for less number of parts. Yeah.
So all of you now aware of the applications of unsaturated polyester resins.
Yes, sir.
Okay.
Sir, in the previous this thing you told about biopolymer getting mixed in the saturated polymer. Here,
It is not a mixed, but out of the bioresources you can make biopolymers for saturated polyesters. I was mentioning.
for unsaturated, it will not be there. Or
For unsaturated, see whatever the raw materials we are using. Okay, whatever the raw materials. Here I have given one example over here. Correct.
hmm,
It can't be directly fully biopolymer, but one of the material or raw materials we can use from bioresources. Whatever itaconic acid I have mentioned here. Have you seen this itaconic acid here?
yeah,
Yeah, this itaconic acid is nothing but a bio-based material.
okay, it's a
Okay.
bio-based only.
Yeah, itaconic acid. Other materials are not been like that. But whatever I have mentioned here, itaconic acid is nothing but a bio-based acid. Okay. So whatever unsaturated polyester form out of it, it is we can call it as a bio-based unsaturated polyester resin
Okay.
because one of the raw material we are using bio-based.
And this also get decomposed, huh?
What?
Decomposition is possible in this, or
No. See, whatever the biodegradability you are asking, correct? This
biodegradable.
is not fully biodegradable.
Okay.
Okay, because one of the raw material we are using from petroleum source or synthetic source.
Okay, okay.
Okay. So now the what is the future of this thing, like as we are already discussing the biodegradability, correct? So already I have mentioned like majorly we are using petroleum based polyesters, correct? But nowadays people are moving for biopolymers in that way. So already I have mentioned some examples in saturated polyesters. One of the example is nothing but your PLA, polylactic acid, correct? Nowadays research have been going on that things, by which we maybe in future we will get some biopolymers or polymeric polyesters to use or to single use in that way. Maybe I don't know now, because some research in many of the things in many of the areas are going on. So this is nothing but a future for your polyester. Okay, because polyester is non biodegradable, correct? So these are nothing but the basic differences between your polyester and polyamides. As I already told you, I have mentioned one slide over here. Okay. So
You
as we
mentioned,
have
sorry to interrupt you, you mentioned that it's a non-biodegradable, right?
what?
That polyester, right?
Yeah, whatever the polyesters like polyethylene terephthalate, polybutylene terephthalate, synthetic polymers I am telling about, which comes from your petroleum sources. Petroleum sources means whatever the monomers we are using that are synthetic, that are non biodegradable. But if you are thinking biopolymers, polymers like polylactic acid, correct? Polylactic acid, one of example I have mentioned in that slide, correct? That is, we generated it from biosources. Biosources means the sources which are naturally available, correct?
Okay.
So we are preparing or we are producing that polymer. What are the polylactic acid, which is from biosource. So that polymer is biodegradable. Okay.
Okay.
So that polymer is nothing but again the class of polyester.
Okay.
Polylactic acid is nothing but a polyester. Okay. That polyester you can consider as a biodegradable.
Okay. Let's suppose we can say composite like in hand layer process.
Yeah, that is not the biodegradable.
Okay.
Okay.
And what is the end usage means later on what we can do?
Later on, people used to discard it directly. Okay, because whatever the thermoplastics are there, suppose polyethylene terephthalate, one of the thermoplastic is there in case of polyester, we can recycle it. Means you can again make shredded, you can shred or you can cut it into many small pieces and you can again remold it. After remolding, you can again reuse it, correct? Thermoplastic
Yeah, yeah, yeah.
polyesters, or you can say saturated polyesters. But in case of unsaturated polyesters, after hardening or after cross-linking the polymer, you can't recycle it or you can't reuse it afterwards,
Okay.
after application.
Okay, got it. Yeah.
Yeah, it will directly cross-link.
Yeah, yeah.
That cross-link plastic we can't use.
Yeah.
Okay, can't use means we can't reuse it or you can't recycle it.
Any future scope of that, can we make it
And
green?
means many of the researchers are going on to depolymerize the things. After
And
depolymerizing, and again we can use that raw materials for further applications in that.
any progress in this that's field?
Many of the things, that progress is in only the research field, not at industrial level.
Okay.
Yeah,
Because generally in SMC, all these composite we are using
yeah, yeah, yeah. Correct.
non-usable again.
Yes,
So if we can get
they
the
directly discard it.
reusable, that will be good. Yeah.
Yeah.
Challenge. Yeah.
Okay. So difference in polyamide and polyester. Nylon is a polyamide family. Polyester is nothing but your again your polyethylene terephthalate in that way. Okay. Have you seen over here the difference in the mechanical things, or you can say, oh, see, if you see the durability part, correct? Nylon fabrics are usually durable, abrasion resistance, as well as resistance to many chemical and oils, correct? Nylons. Then your if some major like I think I have mentioned or not, I don't know. But generally, whatever the we I have mentioned earlier, suppose you have told me like a nylon is having, means majorly the self lubricating property nylon is having more that case. Okay. So this is for today only. Okay. Now in next lecture, means tomorrow's lecture, we will we will see the next class of polymer. Okay. Hello.
Yeah.
Okay. So for today, this is the part over here. Okay. So today we have learned the polyester. In that polyester as well, saturated polyester and unsaturated polyester resins. Okay. All of you have understood the part.
Yes, sir.
Okay. So tomorrow we will see polyacetals. Okay. We will start with polyacetals. Okay.
Okay, sir.
So we'll
Thank you,
meet.
sir.
Okay. We'll meet tomorrow. Okay. Thank you.
Thank you, sir.